Hi friends, very good evening and thank you for joining in today. So could you please confirm in the chat window if I'm audible and visible so that we can get started in another 4-5 minutes? Can you just confirm that please? I have the chat window open on my phone. So if everything is looking good, let's jump in. Hey, good evening folks. Thank you for joining in. And today we are starting discrete math. Okay, good. So we'll just get started by 7:03, 7:04. So today is discrete math, so let's get started. Again, since we're starting a new subject, you'll encounter a few easier questions today. Of course, there are a couple of medium tricky ones, but slightly on the easier side. Okay, let me tackle some questions while others join in, right? So this is by Devdeep, who says, there are so many notations and concepts in graph theory. How do I remember all of them? Again, it's fairly confusing, to be honest with you. At least the way I think about it is, for example, what is the definition of a simple graph, right? So what I used to do, even when I was a student, even I do it now, like today morning I was revising all the notes once. I just make short notes. For example, I'll read something about simple graphs, notes from my tablet. In the notes, I just wrote simple graph is undirected, unweighted, no loops, no multiple edges. Just one line definition, right? So you have to get comfortable with the terminology because there are so many nuances, right? There's so many subparts, but don't worry too much about it. With a couple of revisions, just make short notes. Think of it like a quick revision thing for all the terms that you encounter, and you can quickly revise it in like 10-15 minutes. All the terms in graph theory, with some practice, you can do it in like 10-15 minutes. And when you solve more and more problems, you'll get comfortable with it. So there is nothing that you have to worry about per se. It just takes a little bit of revision and practice. That's it. So Arun says, what's the ideal time to finish the syllabus? There is no ideal time. Because what is important is not when you finish, but how well you have studied in your first iteration. That's what matters more. We have seen people who finished their first iteration in January last year and still got a good rank in the top 100 or the top 200. We have seen people who finished the first iteration in July of last year and still didn't crack because they were not thorough with it. So it's not just when you finish, but how thoroughly you do it in the first iteration with practice problems, going through the concepts, multiple revisions on weekly, monthly, quarterly basis. I think that's the key here. We've seen people who just do one iteration and maybe a last 1 month revision and still get a brilliant rank in GATE. Okay, so instead of worrying about, hey, I'm being backlogged or am I lagging behind my peers, don't worry about it. Try it. Again, everyone's preparation would be different. Try and do the first iteration thoroughly. That's the key. Cool. Okay, this is a nice question. I think it's Elias ATA. So what should be my preparation strategy if I start today? Very nice question. So let's assume you're in the last week of July. So you have something like August, September, October, November, December, Jan, Feb. You have 7 months. So you have to put in slightly more time as compared to if you're doing it maybe 2-3 months earlier. So on an average, you should put in like 4 hours a day. If you do it 4 hours a day consistently, day in, day out, and if you are focused on like 4 hours of uninterrupted effort, 4 to maybe 4.5 hours, you can finish the whole syllabus in 5 months. 2 months, revise, 2 revisions before the exam. That's the strategy if you have 7 months ahead of you. That's more than sufficient. Even if you have 6 months ahead of you, you can comfortably finish the GATE syllabus. 6 months is all you need to prepare for GATE. Again, we've seen people do it in a shorter period. But an average student, 6 months is more than sufficient if you put in the necessary effort. Okay, cool. Again, we'll wait for a couple of minutes before we dive into it because we started this session a little late. I'll take one more question, then we'll start the questions. And at the end of the session, as usual, we will have a Q&A again. So this is good. So this is how many times should we practice GATE questions? It's not about how many times you practice, it's how much effort you put in to build your problem solving skill again. So for example, like we have seen students who just solve like 1,000 problems, but those 1,000 problems, they pick up a problem, they struggle through the problem. They literally struggle through the problem and don't see a solution. They try it multiple times to be able to build that problem solving skills. Once you're building the problem solving skills, it doesn't really matter whether you solve a problem 10 times or 20 times or only once. So we say solve a problem once, but solve it thoroughly. That's the best strategy. And problems that you're not able to solve, keep them as part of your revision strategy and debug why you're not able to solve. Because problem solving skills are the most fundamental, one of the most fundamental things that GATE is testing you for. Okay. So with that, again, we'll come back to general Q&A in a while. So let's jump into the live session today because it's 7:04, 7:05. Okay, can everybody see my screen clearly so that we can get started? Is my screen clearly visible? Can people confirm if my screen is visible so that we can get started? Again, our team is also trying to answer some of the questions in the chat window, but I'll come back to it at the very end. Cool. Sounds good. So somebody is asking a quick question about the blogathon in our applied AI course. We are just compiling the results. We just got all of them a while ago. We will compile the results and send out emails probably later tonight, right? So today is our deadline internally. So we'll do it by end of day. Again, back to our topic here. So, okay, so this is the first live session in discrete mathematics. Again, as we mentioned earlier, some of these live sessions will be publicly available on YouTube. Some of them will be private, which means they're accessible only for our course enrolled students. This live session on today is publicly available. I believe the next live session, which is on Friday, is only for course enrolled students. Okay, so let's go with discrete maths. Again, since this is the first session, you'll encounter slightly easier questions, but we'll keep increasing the complexity of questions as we keep going through discrete math in general. Cool. So here comes the first question. Again, please solve the questions because that's the intention of this live session. We will come back to your general questions at the end of the session. Again, simple MCQ problems. This is about sets. Again, somebody is asking, are all these live sessions accessible to course enrolled students after the live session? Yes. So everything will be embedded as part of the course structure in its respective location. So in case you have not yet prepared this, you can watch it later, obviously. Okay, let's solve it. Let's solve it, folks. I'll surely answer the general questions at the end, but let's focus on the question at hand. Again, our mentors are also answering some general questions. This question is like an easy question by GATE standards. It's an easy question, it's an MCQ, maybe slightly tricky, but not too much. I see a few of you who got wrong answers in the chat window. Please revisit your answers. This is like a typical 1 mark type of question, easy question from sets in GATE. Okay, so most of you got it right. So let me just explain the solution quickly. So let's look at these two sets, x and y. Y seems like a simpler set to work with. So if you see y, what is y? Because n belongs to set of natural numbers. So n will be 1, 2, 3, 4, etc. right? Because 1, 2, 3, 4, so on and so forth. So then y will be 0, 9, 18, 27, all multiples of 9. Right? That's what y is. Now what about x? X is slightly trickier. Of course, there are multiple ways of solving it, but a more rigorous way of solving it is, one thing that we understood is these are all multiples of 9, right? Now, can we get something, because what we want is x union y, and if you look at all the options, we want to understand what x is. One strategy that you can employ is, okay, you can plug in each of the values and see what x is, right? And then eliminate options. That is surely one strategy that some folks do. For example, if you plug in each of the values, then you get, so if you plug in n equals to 1, you get a 0. If you plug in n equals to 2, you will get 9, then you get 54, then you get 243, so on and so forth. One quick observation that some students make is, hey, all these are also multiples of 9. Anyway, all multiples are here, but all multiples are not here. So it could just be that, again, you can eliminate options and say, hey, if this is your set y, your set x is a subset of y. So x union y will be y. That's one way of solving it. But if you want to solve it more rigorously, you can actually do it this way. Again, we know, I mean, just by looking at this sort of setup, you know that all the x's that you're getting are also multiples of 9. Empirically or observationally, you can say that. But can you do that more rigorously? Actually, if you expand on this, it's actually very simple. So you want to see if these are multiples of 9 or not, right? So one way to break it is you have 3. We know 3 squared is 9. So can you somehow use some simple math from high school days to break the equation down? You can say, hey, 4 power n, I can write it as 1 plus 3 power n minus 3n minus 1. So this is what all the values will be. Now, this is like a simple polynomial expansion, right? So what would this be? This will be 1 plus n choose 1, 3 power 1, plus n choose 2, 3 power 2, so on and so forth, n choose n, 3 power n, right? Of course, you have minus 3n minus 1. Now, if you observe, this minus 1 and plus 1 would get cancelled. This is nothing but 3n, because n choose 1 is n. So this and this would also get cancelled out. So what you're left with is this term. Now, if you see, you can take 3 square out, 3 square common. If you take 3 square common, you get n choose 2 plus n choose 2 into 3 power 1, so on and so forth, n choose n into 3 power n minus 2. So what you see here is all these values are also multiples of 9. Look at this, all these are also multiples of 9. But not all multiples of 9 would be present in the set X. Again, you can see this empirically or observationally. All of these are multiples of 9, but all multiples of 9 are not there here. So x union y will be equal to y, so D is the right answer. Again, in an examination setup, again, this is the more rigorous mathematical way of solving it. But if you can figure out the pattern and say, hey, both y is all multiples of 9, these are some multiples of 9. Some multiples of 9. Then you can easily and trivially solve this. It's an easy problem, right? Cool. Okay, so let's go to the next question now. I mean, fairly simple, easy 1 mark question. Okay, cool. So let's go to the next question now. Here it is. Very simple, typical, your 1 mark graph theory question. Very typical of GATE. So this is a typical graph theory question and typically 1 mark type of question here. It's an MCQ. Again, think of it as a quick warm-up Today we have put the easy questions first and then go to the couple of medium questions. In the next live sessions, we'll keep increasing the trickiness and mediumness of the questions. Again, you'll actually encounter these types of questions in GATE. Again, if you see even the last few years of GATE questions, almost 55 marks you can easily score just by solving easy questions, not even medium questions or trickier questions. Just easy questions like these is just slightly more than 50% of the marks in GATE. Actually, somebody is asking a nice question in the chat window. What is a k-connected graph? This question is all about knowing the basic terminology of graph theory. The reason I say this is an easy question is because you just have to know the terminology in graph theory and a couple of simple rules of counting. If you know that, you know the solution, right? It's as simple as that. Anyway, I'm waiting for your I think a couple of people have question about the previous answer. You can always go back and see it. We have clearly shown that one set is a subset of the other. So just go back to that in the video and rewatch it. It will be clear. Okay, so, I'll wait for a few more seconds and then we'll go into the answer. Again, this is straightforward. If you know what is a k-connected graph, if you know some basic counting, that's it. Okay, so let me see, have any others have answered? Okay, let me answer it. I think most of you are a little stuck on what is a k-connected graph. Again, another term for k-connected graphs is called k-vertex connected graph. Okay, so the terminology is also fairly commonsensical. So this is also sometimes called as k-vertex connected graph, right? So what it means is every node in your graph is connected to at least k other vertices. Right, so every node is connected to greater than equal to k other vertices, which means the vertex connectivity is k or more. Which means, again, if you can think about it from the perspective of cuts. If you think about it from the perspective of cuts, if you want to create a disconnected graph here, right, a graph which is not connected, you need to remove at least k vertices. Okay, so the k connectedness can be thought of from just simply vertices, that every vertex needs to have k or more vertices that it is connected to, or you can think about it from a cuts perspective and say, hey, I need to remove at least k vertices to disconnect the graph. Okay, so all this connectivity, k connected graph basically means k vertex connected, which is what this means. Again, the terminology is fairly straightforward. That's why I said at the very beginning, again, there are some terminology related simple questions like this in GATE. So one simple technique that I would recommend here is just make a short notes with all definitions. So for K connected graph, I mean, this is what I actually draw in my own notes, right? So for K, again, each of us have a different way of remembering. For me, imagine if this is vertex I, for all I, each vertex has greater than or equal to K edges. That's it, simple. This is the simplest way. Again, it's talking about connectivity, which means vertex connectivity here. Now let's solve the problem. So what do we have? We have vertices like this, a bunch of vertices. Each vertex is connected to K or more. Look at this. This is connected to K or more other vertices, right? So now if you look at this, so let's assume E is the number of edges, right? Let's assume E is the number of edges. Then if you count all the, if you count the degree of each of the vertices, count the degree here, count, again, this is also connected to K or more vertices and things like that. So if you count the degree here, look at this. So there are n vertices, right? In an n vertices graph, each vertex has K or more edges, right? So if you look at the total sum of degrees of each of the vertices, it will be greater than or equal to 2K. And we know that this whole thing is 2 times E, right? You know this, right? If you take the sum of all the degrees, this is, if you look at the sum of all the degrees of the vertices, that will be equal to 2 times the number of edges. Okay, this greater than equal to is there because each vertex can have greater than equal to K vertices. Can have a degree of greater than equal to K, I'm sorry. Or in other words, every vertex can be connected to K or more other vertices. So this degree is greater than equal to K, right? So if you see, the total number of edges is greater than equal to n into K, which means the number of edges is greater than equal to nk by 2. Very simple, right? So the answer here is C. It's a very, very simple question if you think about it. All you needed to do is 2 things if you think about it, right? All you needed to do was, you needed to know the definition of what is a K connected graph. So the first thing is you needed to know the definition of it. The second thing is you needed to know that the sum of degrees, right? The sum of degrees of all the vertices Vi equals to 2 times the number of edges. That's it. Only 2 regions, right? Only two formulae, only 2 concepts. Okay. This is called the average degree theorem, obviously, but it's common sense. Okay. Again, I don't remember the names of theorems very often, but there is one thing that you have to know, which is what is the definition of this. And for that, since I am very similar to many of you, I'm bad at remembering formulae or bad at remembering definitions, I make a short notes, right? Very simple stuff here if you think about it, right? Cool. Okay, there is another strategy that one of the students who is anonymous says, I've just eliminated these options. Yes, that's certainly a valid strategy because this is a simple MCQ. You can draw something like this. Look at this. This is a 2 connected, right? This is a 2 connected graph. A square like this is a 2 connected graph. You can just simply eliminate options using these types of strategies, right? Similarly, if you have a tree, somebody is asking about a tree, right? A tree is a 1 connected graph because even if you remove one edge, you're done, right? It will get disconnected, right? So very simple strategy, very simple question. It's all about knowing the definitions and some basic inequalities and equalities like this in graph theory. That's it. Cool. So another question about relations. Again, we are starting easy because we are just starting discrete maths. Yes, you can take, for the previous question, you can take various examples and solve it. That's certainly a strategy, but I was trying to go for a more rigorous solution. So every year in GATE, you will have some easy questions. Almost even in the last 3-4 years, 55 marks roughly are easy questions. Again, discrete math is not hard. Many people have this misconception that it's hard. If you're careful, you will get it. It's that simple. Again, we will take general questions at the end. Please solve the questions here because the purpose of this session is problem solving. I'll surely answer your general questions at the end. Again, a very simple question. Again, you do encounter such questions in GATE. Again, this is a simple question, folks. I see a lot of you making mistakes here, so please rectify. This is an easy question. This is like a typical, again, 1 mark question from relations. I see some of you making mistakes. Please be careful. Please be careful with this. I see people making really silly mistakes. This is a simple question. Nothing too hard about it. If you know the definitions of what is reflexive, symmetric, and transitive, and of course equivalence, it's straightforward. Okay, I'm waiting for some of you to correct your mistakes before I will go into the solution. Okay, so let me explain it, right? So your relation is this, right? Your A is related to B, right? If 1 plus AB is greater than 0. That's what it's saying. Now, what is a reflexive relation? Reflexive relation is if A is related to, A should be related to A, right? That's what it means, right? This is what reflexive means. So is A related to A? Let's just find out, right? So imagine if A and B both are A, so then you get 1 plus A squared. Is it greater than 0? Right? Because you look at this. This is a relation on set of real numbers, which means A comma B belong to set of real numbers. Right? Because of this, square of any real number is positive. Right? So this will always be positive. 1 plus positive value will always be positive. So yes, it is reflexive. Very simple. Now what about symmetric? Right? So what does symmetric basically means? If A is related to B, then B is related to A. Very simple, right? Very simple. That's what it means. Now let's try to figure this out, right? So imagine if somebody tells you that 1 plus AB is greater than 0. Can we imply that 1 plus BA is also greater than 0? Yes, because AB equals to BA. Simple high school algebra. So this is also trivially symmetric. Now comes the more interesting thing. Is it transitive? Right? So is it transitive? What does transitivity mean? Transitivity means if A is related to B and B is related to C, then A is related to C. Simple definitions, right? Now is this true? Now if you are careful with this, you have to be slightly careful. While this question is easy, you have to be careful. Right? So if I choose values of A, B, C carefully, let's try to break this. Now imagine, because B can be any real number, right? So imagine if I choose B equals to 0 first. See, if I choose B equals to 0, because look at this, A is related to B, B is related to C, right? This is already given. Given this, can you conclude that A is related to C? That's what we are trying to figure out. Now if b equals to 0, then what happens to 1 plus ab? This will always be 0, so this is 1 greater than 0, right? So if b equals to 0, for whatever value of a, whatever the value of a value can be anything, a will still be related to b, right? Because if b value equals to 0, this whole thing will become 0, right? Similarly, whatever the value of c, look at this, whatever the value of c. So if b equals to 0, for all values of a will be related to b. Similarly, b will be related to c, because b into c, whatever the value of c is, b into c is 0, 0 plus 1 is always greater than 0. So what this is saying here is, now whatever the, so let's just take a simple example, right? Imagine a equals to 1 and b equals to, let's say, minus 1. I'm just cooking up an example. I'm cooking up an example in such a way that a is not related to c. Look at this, I'm cooking up an example where a is not related to c. Because if I take 1 and minus 1, multiplying them will give me minus 1 plus 1. 1 minus 1 is 0. So a will not be related to c if a equals to 1, b equals to minus 1. But if b equals to 0, a will always be related to b, right? So if you take this simple example, again the catch here is to recognize that what if I have b equals to 0 in this type of transitivity? That's the key idea here. So if b equals to 0, a, for any value of a, including a equals to 1, a will be related to b and b will be related to c if c equals to minus 1. But that does not imply that a is related to c. So which means it's not transitive. So only if it is reflexive, symmetric and transitive, it is equivalence. So it surely is not equivalence. The only appropriate option is a. And this question is slightly, again, I wouldn't call it hard. I wouldn't call it even tricky. It's easy. Like in GATE, they won't give you such a trivial problem also, right? Here the case that you have to think about with respect to transitivity is just this. The key here is what if, the key observation is if b equals to 0, for all values of a or for all values of c, this will hold. That's the key here. That's it, right? So a is clearly the answer. That's why I said this is an easy question. And I've seen a lot of people give D as the answer. Remember, these are questions which are easy to score. All you need to know is the definition of reflexive, symmetric and transitive, and be careful when you're trying to check out some options. That's it. Again, this question can be, depends on the question paper, but it could be a 1 mark or even sometimes a 2 mark question, right? But simple one. It's a straightforward, simple question. Okay, so let's go to slightly more interesting problems. Okay, here is a nice question. So what this means is it is a set of all x. That's what this means. Okay, just to be careful, just to be clear here. This is the set notation. Just to be clear here, this is set. Right? Just in case there is a confusion there, because most people use the curly braces. You can also use the square parentheses sometimes. So one of the students has a nice question. How do you check which corner cases to look for? You have to try and break, you have to try to construct counter examples. It is through the ability of constructing counter examples that I myself came across this ABC values in the previous question. Again, please be careful with this question. This is not a trivial one. You have to be careful. Again, this function is the absolute value function. I hope everybody knows that, right? Standard mathematical function. This is a good 2 mark question in GATE. Please be careful. I already see people making silly mistakes with this question. Please double check your answers. Let me give you a hint. There are so many silly mistakes. I want to give a hint. Draw the number line. Please draw the number line. Like this is something that you probably learned in your 7th or 8th class, right? Please draw the number line. And then think about these inequalities and sets. Because visually you will be able to grasp it better sometimes. If you're not comfortable with algebra, draw the number line, for heaven's sake. I see many of you committing silly mistakes. Please draw the number line, for heaven's sake. That's the technique for problems like this. I see almost all the 4 things being picked by students. This is your 0, this is your -1, this is your -2, this is your 1, this is your 2, right? So on and so forth, minus infinity and plus infinity. The catch here is the absolute value. So please be careful with that. If absolute value was not there, this is like a high school problem. Actually, this problem can still be solved by high school students, by the way. Yeah. So there are many ways of solving this, guys. You can do it arithmetically by saying, hey, what does each set contain? There are many ways of solving it. I'm not saying there is one right way, but if you draw the number line, it gives you the intuition and you avoid silly mistakes. That's all I'm suggesting. I'm not saying this is the only way to solve it. Okay, let me solve it using both ways then, when we solve it. I've seen more than 50% of students making a mistake till now. I hope they correct it with the number line idea. Good. Now I'm seeing more people thankfully correcting their mistakes, which is always encouraging. Okay, I'll wait for a few more seconds and then go into the solution. Okay, so let's solve it together, right? So what is set A? Set A is all the real numbers. So x belongs to real numbers such that absolute value is less than 1. So you know that it's strictly less than 1. Remember that. Right? It's not less than equal to 1. So if a number lies from this place to this place, again, I'm putting the simple parentheses, okay, to say like for example, if you draw this, it means if you say a comma b, it means a and b are not included in this, right? You know this, right? It's called open interval and closed interval concepts. If you say this, it means both a and b are included in this set. Simple set theory notation from high school, right? So I'm just trying to use the same notation here. So your set A basically has all the numbers from here to here, but it doesn't include -1 and 1. And to be really sure, take -2. What is the absolute value of -2? It is 2. Is 2 less than 1? No. So any number that is here, any number from here to minus infinity, that number will not be in set A. Similarly, any number that is here will not be in set A. Similarly, let's look at set B. This is the more interesting set because there is also a greater than equal to here. Okay, so now again, I'm just going to draw it step by step carefully. Now, okay, let me pick a different color here. Okay, so I'm picking a slightly different color. So what is set B? So, okay, it says x minus 1, the absolute value of this is greater than or equal to 0. Let's just plug in values, right? So if I plug in x equals to 0, I'm just plugging in values. If I plug in x equals to 0, this is -1, absolute value of -1 is 1. So 0 will be there in this set. Will -1 be there in this set? Yes. -1 minus 1 is -2. Again, I'm just thinking through carefully. Of course, there is also an algebraic way. I'll show that to you in a couple of minutes. But let's just think about it from a visual perspective. If x equals to -1, -1 minus 1 is -2. Absolute value is 2, it is greater. So this is also there. Now, will 1 be here? Will 1 be there in this set B? This is set B, right? 1 minus 1 is 0. It's not greater than or equal to this. So this won't be there. Will 2 be there? Let's ask that question, right? So anything between 1 and 2 will not be there. So take 1.5. If you take 1.5, 1.5 minus 1 is 0.5 and the absolute value is 0.5. 0.5 is not greater than or equal to 1. So anything between 1 and 2 will not be there. Will exactly 1 be there? Yes, exactly 1 will be there, right? And all these values, if you take -2 minus 1 is -3, absolute value is 3 greater than 1, yes. So all the values from here to minus infinity, all these are there in B. Look at this, from here to here is there in B. I'm just using a slightly different color, but these colors are looking more or less the same. So let me just change the colors a little. Just give me a second. Okay, let me use blue just so that it stands out, right? So this blue is my B. Now, we said that everything between 1 and 2 will not be there in set B. But will 2 be there in set B? Yes, because 2 minus 1 is 1. So 2 will be there. Will 3 be there? So let me draw it carefully. So will 3 be there? Yes, 3 minus 1 is 2. Absolute value is 2. So everything from 2 up to minus infinity will also be there. So now what is the union of both of them? Look at this. What is the union of both these sets? Right? Simple logic. What will be the union of both these sets? The union of both the sets will be, look at this. This whole thing is there. If you think about it, this whole thing is there. Right? The union, right? It's not intersection, it's the union. This whole thing also will be there in the union. Right? So this is A union B. Now they are saying A union B is the whole real line minus some D. Right? Simple logic. So what will that D be? Now, 1 second. A union B is R minus D. Just a second. Just a second. Give me a second. I hope I'm not making a mistake. So set A, because I've not drawn this on my notebook, so I'm just trying to solve it live with you. I solved it using algebra in my notes. So 1 second. So set B is 1 in set B. Yes, 1 is there. Is 2 in set B, because there is an equality, it will be there. So what is the union of them? This 1 itself is not there in set A, but it is there in set B. So we have the whole thing. Cool. Okay. So this whole thing will also be there. Okay, cool. Again, I hope I don't make a mistake. 1 second. So somebody is saying 1 will not be in A union B. 1 second. So does B contain 1? B contain 1. No, B won't contain 1. I'm sorry. No. So B, so let's just plug it in, right? Probably I'm making an error. Let me do it carefully, just to be sure. Okay, let me do it step by step. I think I made an error somewhere because it's not fitting into the algebra that I thought of. Just a second. Let's solve it together. No problem. Let me get a black color here. So this is your A. Now what about B? Let me just do it slightly more carefully. So will 0 be there in B? Yes, 0 will be there. Will 1 be there in B? No, right? Because 1 minus 1 is 0, it's not. Will 2 be in B? Yes, okay. I think that's the mistake I made. Yes, I think that's the mistake. Sorry. Okay, so 0 will be there in B. So your B is from here to here, right? So this whole thing is your B. Your B will be this and also this, right? Now this is correct, right? Just, right? 1 won't be there. I think that's the correction. I'm sorry. Okay, so I'm sorry, I made a silly mistake there. So 0 be there. When I was doing the analysis, I was doing it correctly. Can you just confirm if this is correct, if you got this correctly, if I got it correctly also? Is this okay? Can you just confirm that? Is everybody convinced with this? So 0 will be in B, right? But 1 will not be. Now if you take the union of both of them, what will the union contain? Now the union will not contain this part, right? So because it's a union, right? So it's a union. So it will not contain this part. So in the A union B, you will have this whole region. You will have this whole region, right? You will not have this part. You will not have this part. That's the essence, right? So sorry, it's a union, right? I'm sorry, my bad. Again, what am I thinking? 1 second. So union is, this will be there. So 1 will not be there. So this whole selected region will be there in the union, right? So whatever I have written it here, this is your A union B. This is your so this part is also A union B. Just that exactly 1 will not be there, 2 will be there. 1 will not be there, 2 will be there, right? So now A union B is R minus D. In a whole region, this is your whole real line. What do you have to subtract to get this? You have to include 1. So your D will be in the real line. What do you have to remove to get this union? You have to remove 1, but you should not remove 2, right? So your D is from here, including 1, but excluding 2. So this region is your D. And what would that be represented using? B. This is the number line way of doing it. There is a more algebraic way of doing it. I hope this is clear, right? This is clear, right? It's a union. Yes, it's a union. So I hope this is clear. Okay, let me solve it algebraically that I've solved earlier. This is easier. This comes naturally to me. The algebra also comes naturally. So another strategy that you can employ here is, look at this. This basically implies, what does this imply? This means that your x lies between -1 and 1. That's what this implies, right? Because you can write this as x less than 1 or minus x less than 1, right? So minus x less than 1 basically means x greater than -1. Simple. So what does this mean? This means x, again, whenever you have absolute value function, you can write it as this or this. And this, by multiplying both sides by -1, you can simply swap the signs. That's it, right? So what does this first set consist of? X less than 1 basically implies that -1 less than x minus this, right? So this is what it means. Now, what does this mean? This means -1 to 1, right? It doesn't contain -1 and 1, but it contains this. That's what this set basically represents. Now, what about B? X minus 1 is, greater than equal to 1. What does this mean? This means x minus 1 is less than equal to -1 or x minus 1 is greater than 1. Simple logic. You just multiply one side with negative. That's it, right? So what does this mean now? This means, if you think about it, what is this? This means that you have all the numbers. Again, you can further simplify this, right? So this basically implies that x is less than equal to 2. Sorry, x is, x is, so if I take this to the other side, it becomes +1. So x is less than equal to 0 or x is greater than equal to, if I take this to the other side, x greater than equal to 2. So what is this set now? This set is, okay, so let's write it in the set notation, -infinity to 0. That's what this means, right? X less than equal to 0, which means -infinity to 0, union 2 to plus infinity. Sorry, I can't use this because -infinity is not a real number, right? So this is infinity. This is what you have. This is your A, this is your B. Now if you write A union B, let me just change the colors here. If you write A union B is the union of this and this. That's what it's a union of, right? Again, you can think of this union logically by just drawing the number line. That is where the confusion is. I think the biggest confusion in this problem is that what is A, what is B, and to visualize it. That's the confusing part. So this problem is actually not hard, it's just slightly confusing. So now what will your A union B be? A union B will be all the numbers from minus infinity, right? Because minus infinity to 0 is here, right? Then you have from minus 1 to plus 1 is here, right? So you will have everything up to 1. On the negative side, everything will be there, but up to 1. Union. On the positive side, you have from 2 to plus infinity. That's what A union B is, right? Again, I'm just solving it arithmetically. Look at this. Minus 1, see, minus infinity to 0 is here. 0 is also included. Here we have it till minus 1, but we don't have minus 1 itself, but minus 1 is included in this. We don't have 1 here, right? That's why union of these two, if you just do the union of these two, you will get this. This part I've just copy pasted it here. Now we can again visualize this from a number line perspective, right? So what does this mean? From minus infinity up to plus 1, not including plus 1, and from 2 to plus infinity. So what is left? This region is what is left. And that region you can easily get it as equivalent to your set B, right? Because it will include 1 but exclude 2. So B is the answer. So there are broadly two ways of solving it. I solved it algebraically in my notebook, but doing it using the number line also helps, right? Is this clear? Again, I made a silly mistake with respect to drawing B earlier. Thankfully, I corrected it quickly, just being careful. Is this clear now? Can you just confirm if this is clear or not? Then we can go to the next problem. I'll just wait for the confirmation. Okay, cool. Again, I personally prefer the number line approach because it is visual, but you have to be careful not to make silly mistakes. Thankfully, I recognized my silly mistake quickly and corrected it. If you don't do it, I would have made a mistake here. So this question is actually a tricky question. It's actually medium level and tricky by gate standard. It's just tricky because of the absolute value nature of things. Again, because of the closed intervals and open intervals. That's all. It's not a hard problem. Again, I am not surprised if a similar problem you find it in other competitive exams like IIT, JEE, etc. Okay, cool. Okay, here comes a very interesting question. Please read the question carefully. Please read this question very carefully. It's a nice question from graph theory. I'll take your general questions at the very end. This is a very nice question. Please read it, double read it if required. I'll give you a hint after a few minutes. This is an NAT. It's a good 2 marks numerical answer type. This is not a trivial question, obviously. That's the reason why this question is asked. So the hint that I would give you is write down all the numbers, all the information that is given to you and all the facts given to you. and then using all of them, try to compute the number of connected components. This is not a straightforward plug in the numbers into a formula. This is a good 2 marks medium level question by gate standard. Think about how will you, there's so much information here. Try to digest all of it, write it down, and think through it. Again, if somebody is asking me what is a connected component, I think you should revise graph theory before you come to this live session, because we expect that you have revised it before the problem solving session. Please revise it. Again, you can just Google search for it. There are tons of nice articles, including Wikipedia. So for all of these, we expect that you have covered, the concepts, right? Because the problem here is to solve. The objective here is to solve problems. I see a few of you putting in your answers. Please revisit your solutions. This is a slightly out of the box question. I see a wide set of answers here. Please revisit your answers. Take your time, it's okay. Once you see the solution, you will say, hey, that's it. So it's not a hard problem. Some of you may think, hey, this is too hard. No, it's not. If you just digest all the facts given to you and work with those facts, it's a simple question. Take your time, it's okay. Okay, I see some of you who got a good answer, but I see a lot of you who have made mistakes on the way. Anyway, I'll wait for a little more while. So one more hint I can give you. So this is the first hint. One more hint is, imagine that there are k connected components. Imagine that there are k connected components. Then what would happen? And remember that the graph does not contain any cycles. This is a super duper important fact. That's my hint. I've given you 3 hints. Now let's solve it. Good. Again, there is a fundamental difference between graph theory and discrete mathematics and graph algorithms and graph data structures. In discrete mathematics, we care about counting things. Like this problem, it's about counting how many connected components are there. In algorithms, we care more about finding a path or finding a spanning tree and how do you represent a graph, right? Those are the problems that we discuss, that we encounter in graphs and data, in graph algorithms and data structures. So while the concepts are the same, there are also disjoint concepts like these. Okay, I see a lot of you getting the answer correct now. Very happy to see that. I'm happy that you're taking the hints. Very nice. Very nice. Okay, so in the interest of time, let me solve it, right? So look at all the information. We have the number of vertices. We have the degree of each vertex. So you can get the number of vertices from this. You can also get the number of edges from this if you think about it logically, right? So what is the number of vertices? 36, 5, 2, 1. You sum it up, you get 44 vertices. So, and it says, hey, no other vertices of any other degree are present. So you can just count to get the number of edges, right? You know that 2 into E is the summation of degrees of each of the vertices Vi, right? You can just use this and say, hey, what is the sum of all the degrees? 30 into 1 plus 6 into 2 plus 5 into 3 plus 2 into 4 plus 1 into 5. If you sum up all of that, you'll get 70. Right? So 2 times the number of edges will be 70. So the number of edges is 35. This is another very interesting fact. Look at what we are trying to build here. The most important thing here is the graph does not contain any cycles. No cycles whatsoever. Now imagine that there are k connected components now. This is also a very important piece of information. Suppose if there are k connected components, right? And let's assume we have Vi let's assume we have Vi vertices, right? Let's assume we have Vi vertices in the ith component, right? In the ith connected component. Let's just assume this, right? Now, there's a very interesting observation that you have to carefully get to. Remember, the graph does not contain any cycles. So what is a connected component? Somebody asked this question, so I thought I'll quickly. So your whole graph, your bigger graph can be broken up into different subgraphs such that this graph itself is connected. This graph itself is connected, right? That's what connected components basically mean, right? So now what is interesting here is that there are no cycles in the whole graph, which means you don't have something like this. This is a cycle, right? So none of your connected components can have a cycle, right? So similarly, you can't have something like this, which means each of these are trees. That's an important. So you have k components, let's say 1, 2, 3, so on and so forth, k components. Then let's say there are V1 vertices here, V2 vertices, V3 vertices, Vk edges. Each of them is a tree because the graph does not contain any cycles, right? So what you have here is a tree. What you have here is a tree. This is tree 1, tree 2, tree 3, so on and so forth, tree k. That's why I said this is one of the most important pieces of information. If it is a tree, if it has V1 vertices, how many edges will it have? V1 minus 1. How many vertices it will have? Sorry, how many edges does this component have? This is component 1, 2, 3, so right? So V2 minus 1. How many edges are here? V3 minus 1. How many edges are here? Vk minus 1. Simple logic, right? So now look at it. Now let's try to form. So we also have these two very interesting facts. Now let's try to combine these facts with this sort of notation. So what is the total number of vertices now? There are V1 vertices in this component, V2 here, so on and so forth. So summation over Vi, I going from 1 to k, right, is 44, right? The total number of edges, how do I get the total number of edges? I just have to do summation I equals to 1 to k. What are the number of edges in this component, which is a tree, in this connected component, which is a tree, which is Vi minus 1. So V1 minus 1 plus V2 minus 1 plus V3 minus 1, so on and so forth. So this is equal to 35. These two pieces of information can tell me what is k. right? Very simple if you think about it. I just need to use these two pieces of information because my summation of Vi, I going from 1 to k, right? This is what I have. Okay, so let me just put it this way, right? So this is what I have. So this summation, look at this. So let me just write it down. Sorry, just let me write it down carefully. 1 to k, Vi is 44. Summation I equals to 1 to k. Vi minus 1 is 35. So this I can now further go ahead and say this is equal to summation over all I 1 to k Vi minus k. So this summation minus k, because there are k ones here, right? I'm just taking it out of the summation. So this value I know is already 44. So what should k be? This value I know is 44. Then k has to be 9 for this whole value to be 35, which means the number of connected components is 9. So the answer is 9. Some of you got it correctly. So this problem is a slightly out of the box, not too much out of the box. Okay, you can easily see all this information is given to you to say, hey, you can get the number of vertices, number of edges. If there are k components, given that there are no cycles, you have to quickly recognize that each of these are trees. The moment you recognize that they are trees, you can get to the fact that each of them have Vi minus 1 edges. And just you plug it back into these equations and you get the solution, right? So this is a medium plus tricky question by gate standards. It's a good 2 marks question by gate standards. It's a really good one. Okay, some of you got it. I'm very happy some of you got it. Okay, cool. Somebody says, how did you get the number of edges equals to 35? That's straightforward, no? Sum up all the degrees. 30 vertices of 1 degree, 6 vertices of 2 degree, 5 vertices of degree 3, 2 vertices of 4. Sum up all the degrees. Summation of all the degrees of vertices Vi equals to 2 times the number of edges. Right? Simple common sense formula in graph theory, right? You just apply that and you get it. There are many ways of solving it, by the way. I'm not saying there is only one way of solving it. But I'm very bad at remembering formulae. Even this formula, I understand it logically. I can derive it right here. There are many ways of doing it, right? But this is a more first principles way of thinking about it. Okay, I hope you got the solution. This was a fun problem creating it. Cool, sounds good. So let's get into the chat now. Okay. So here we are. Please shoot your questions. I'll try to answer as many as possible. I forgot the questions that people asked earlier. If I remember them, I'll quickly recollect and answer. But feel free to type your questions and I'll answer them. Again, not in every case, imagine if there are cycles. How do you now solve this problem? Not always you can solve it with the limited information that's given. So the information that is given, you have to apply that information and apply the constraints of the problem. You may not be able to always solve it. That's important. Then you can get bounds on connected components, but not exactly how many connected components are there. So Satish has a nice question that I got into IIT Tirupati and I want to get into product-based companies. What technologies should I learn? You don't have to learn any technologies because product-based companies don't care about technologies because they know that you will learn them on the fly. Right? You don't have to learn anything complex. If you want for software engineering role, become good at programming, data structures, algorithms. That's it. That's all matters. Right? Because some people say, hey, you have to learn Spark, Hadoop, all of that. No, you don't have to. If you're strong in data structures, algorithms, programming, you will learn them on the job. If you're trying to get into a data scientist role, understand the foundational statistics, the foundational machine learning and deep learning algorithms, and have a good foundational understanding of both the mathematics and the applied aspects, and you're done. It's as simple as that. That's what product-based companies test for. Cool. This is another student, Deboshmita, who says, how to study subjects we don't like. Just tell yourself that if you don't study this subject, this is going to make the difference between getting into a good institute and not. And ask yourself, why don't you like a subject? That's a very fundamental question, right? Because if you connect a subject to its real world applications, there is no subject that you should dislike in computing or in computer science or any other field, to be honest with you. Like my liking to various subjects has changed over the years based on what I learned over a period of time. Of course, my favorite is math because I work in a mathematical area of computer science, but I still love computer organization. I still love databases. I still love computer networks because I see that being used. Like all this wouldn't have been possible without technologies like WebRTC, the TCP, UDP things. So when you connect the concepts to topics, to real world stuff, real world impact, you'll start liking them. That's one strategy. Other is tell yourself that if you skip a subject or a topic that you don't like, this could make all the difference between getting into a good master's program and not getting it. It's as simple as that. So Gaurav says, I've done enough questions but cannot good marks in the test. Why? Again, probably you're lacking on the problem solving skills. Again, there is a video on our YouTube channel which is how to build problem solving skills for GATE. Please check that. Most likely, again, it's my gut feel that probably what you're doing here is you're not struggling through the problems. You're tackling a question, you're solving it. If you're not solving it, you're seeing the solution. It is the struggle that builds the problem solving ability. Seeing the answers will not make, it's like if you go to a gym or if you go to a track and you don't run, you don't struggle through the process of running. If you just see others running, you will never become a good runner. Same story here. You have to struggle through the process of problem solving. If you don't do it, you can solve 20,000 problems. You will never become a good problem solver by seeing answers. That's a very common problem that we see among students, that they say, hey, I've solved 10,000 problems. I ask them, okay, if you've solved 10,000 problems, this type of problem you must have already solved. What is new? Then he would say, hey, I'm trying to recall what sort of problem I've solved. So please build the problem solving ability so that you can solve a wide spectrum of problems with a little practice. That's the key. Cool. Okay, so this is Chandan who says, in the course approximately how many practice questions are covered through practice tests? I don't remember it exactly, but you have multiple types of tests, right? You have solved problems. After a bunch of videos, we solve problems from previous year GATE questions. But across the whole, if you're a course enrolled student, practice tests, mock tests, subject tests, topic tests, all of them included, you have some 5,000 to 6,000 problems. Again, including what you have in the test series of last year and test series of this year. So 5,000 to 6,000 practice problems, not at the subject level, but overall. So Dylan says, I'm going into second year. Should I buy this course? Maybe it's a little too early for you. But if you're very serious about GATE, you can do a 2-year serious GATE stuff and also do well in your coursework while preparing for GATE. But a more appropriate thing in your second year could be do a lot of programming. I mean, that's what we would recommend. Do a lot of programming, data structures, algorithms to build good problem solving skills. Third year, you can start preparing your GATE. Again, we do have students who have started their preparation in second year itself. So they prepare both the second year and the third year, the 2-year type of preparation. And for many of them, we also encourage them, we also request them to do actual coding, right? Because that's an important skill that you don't want to miss out on, especially in the first two years of your undergrad studies. Again, Lakshmi says the GATE is comparatively easier than the applied course test series. Not always. Like within our test series, we have some tests which are slightly on the easier side, some tests which are slightly on the harder side. If you look at the set 2 from last year, that is very similar to some of the slightly trickier test papers that we set, right? So we are trying to prepare students for a slightly harder paper so that even by surprise, one of the sets that you get, like last year set 2, is slightly trickier, you can crack it. That's our objective. It's better to be over prepared than under prepared. So wow, this is a nice question. What is the best time to start full syllabus test series? So as I understand it, I think what you mean is full length tests, right? So we recommend people to take the grand tests, which consist of all the subjects, once they finish their first iteration through all the subjects. Please finish one iteration of everything, then start taking grand tests. That's what we strongly recommend. Because you can use the grand tests and mock tests and all India tests and all of that as a way of revision. So you revise, take a test, revise, take a test, and so on and so forth. That's a more constructive strategy. Okay, cool. This is by Anuj. Should we make notes while studying, or can we skip the step to save time? So Anuj, very nice question. So if you are a working professional and if you're constrained on time, we provide you handwritten notes. You can use them. You can highlight them, at least highlight them with a different colored pen or with a highlighter. And sometimes what we see is students just print it out and then write their additional notes on the side basically, right? Just make sure that you can understand the highlighted notes or the short notes that you've written, because you want to be able to revise these subjects quickly later. That's the objective. If you don't have time, you can just use our handwritten notes for your quick revisions, but just make sure that you're adding these additional points here and there. You can have a completely different notebook where you're writing some of these and then copy paste and then concatenate papers. You can do that also. So Mani says, are you providing any free practice content on your platform rather than YouTube? There are a few practice tests that are publicly available on our platform, but they will be limited, because for every subject, I think we have anywhere from 4 to 10 hours of free content. Some of the practice tests in that content are freely accessible on our platform. Not all, but some. Mostly we try to, the purpose of the freely available content is for students to see our teaching methodology across all subjects before they even enroll. So that's what we have. So Nisha says, I haven't started these subjects yet. How can I use these sessions as of now? As of now, you can't use it because you've not gone through the concepts yet. But all the public live sessions will be on YouTube so that you can come back and rewatch them before the examination. If you're a course enrolled student, all the public and the private live sessions will be embedded in the course structure with respect to the respective subjects at the very end. You can always watch them there. So this is a good question from Ranjit, who says, which option should we choose? So after completing your graduation, we strongly recommend people to get into a job and parallelly prepare for GATE. Don't drop a year, because if you drop a year and if you don't get into GATE, that just increases your career gap. So everyone, we strongly recommend get into a job, even if it's a services company job, get into it. GATE can be cracked if you're disciplined while doing a full-time job. If you're not disciplined, whether you drop a year or not, you will never crack GATE. It's as simple as that. If you know that you're disciplined, and if you've told yourself that you're going to be disciplined, you can certainly be disciplined even in a full-time job. And we see a lot of students in full-time jobs who actually crack GATE. Okay, so that's perfectly doable. So Sarthak says, a very nice question. What is the strategy for those who enroll for 2 years of course? What we recommend for people who are enrolled in the 2-year course is learn as if you're writing the GATE this year. Okay, don't think you have 2 years, because that'll just force you to procrastinate and delay everything. So go with the flow that we are doing right now. Prepare as if you're writing the GATE exam this year. Give your full heart and soul in the very first year itself. I know some of you may be second year students, but that's okay. Don't say, hey, I have 2 years, I'll go in whichever order I want. So it's better to finish all the GATE content. Of course, you might want to do some subjects which are there in your current semester. That's perfectly okay. But in terms of strategy, try and prepare as if you're writing the GATE exam this year and do everything in the first year, so that second year things will become much more easy. This is what I did in my BTech third year. In my BTech third year, when I wrote the GATE exam, I said, I'm going to give my heart and soul in the very third year so that I get the best rank. In the final year, we'll see. I didn't even plan to write the GATE exam in the final year, but I got a 176 odd rank in my third year. So I said, okay, I can improve this in the final year. So my final year preparation or my second year preparation was very focused. I said, okay, these are the topics that I've messed up. These are the topics that I'm not good at. I will only prepare those topics. Other topics I'll simply revise, solve a bunch of problems. We just had previous year questions then. Just solve it, go cool, go to the examination hall. There is no pressure, you deliver. It's as simple as that. Cool. Is group theory syllabus complete? Yes, in the course videos it's already there. In terms of live sessions, it's not yet done. So today, if I'm not wrong, we just did basic graph theory, sets and relations, right? Yes, graph theory, sets and relations. I think, if I'm not wrong, next live session or the one after that is groups groups, lattices, and all of that. Okay, this is a nice question from Sudesh. Sudesh says, I have 5 years of experience and I work at a product-based company and I'm keen to go to research area in future. Again, if you're planning to go into research, again, if you're already at a product-based company with 5 years experience, it doesn't make a lot of sense to write GATE for a master's degree and then to go into product-based company again. It doesn't make any sense. But if you want to go into hardcore research, certainly GATE is one of the smoothest ways, because I mean, this is something that I've seen a lot of my friends and juniors and seniors do, which is they already have some work experience. They are very clear that they want to pursue a PhD, get into hardcore research. So they crack GATE, get into the top institute, 2 years masters. They don't focus anything about jobs. They focus only on getting research papers published. And then once they finish their masters, they go to some of the world's top universities. Some of them even continue with the same professor if they already are clear that this is what I'm going to do in the next 2 to 3 years. And you can convert your masters to PhD, or you can go to a better university or a better research lab. If you want to get more international exposure, you can go to some of the best research labs and then do your PhD. So people do that. We have seen a lot of people. Even last year, there are a few students from product-based companies, top product-based companies, who wanted to get into research, who cracked it. Cool. So can you talk to us about IIIT PGE? I don't know. I'm not updated on the results yet, but I really liked their question paper because they gave 2 programming questions. I hope GATE also moves in that direction, because that's the right direction. They gave simple questions, nothing hard. They gave 2 simple programming questions. I think one question was to implement the absolute value function. You just have to handle the boundary cases gracefully. The second question was, given 2 integers, you have to print all the prime numbers between those integers. I think those were the 2 questions. Simple questions, but it is testing your programming skills and programming ability and ability to handle boundary cases. I don't know about the results, but I really like the examination pattern. And I've actually recommended to some faculty whom I personally work very closely with, faculty at Institute of Science, etc., and said, hey guys, you should do this for GATE, because you guys are also the coordinators and the key players in GATE. I mean, that's actually good for GATE and for students also. Is applied GATE programming course good for competitive programming too? Yes. So we have a placement prep course along with GATE. So we have a lot of second year and third year students who take this combination because we solve 200 real world interview questions, and that will help you in your competitive programming. Most of those questions are either competitive programming based or actual interview questions at top product based companies. We have 200 solved problems and 300 practice problems. That's something that some of you who are in the second or third year could consider. Is 6 months enough to crack GATE? Yes. The first time I cracked GATE in my third year, I think I spent roughly about 6 months in my preparation. Seriously, the serious effort I've put in was only 6 months. So for 6 months, if you're putting 4 to maybe 5 hours, I'm talking about an average student. A brilliant student might require to put in lesser hours. A less than average student might require more time. So if you're putting in 4 to 5 hours roughly a day, 6 months is more than enough to get a good rank within the top 200, 300 in GATE. Which is better for data science, IIT Bombay or IISc? Both of them are good, to be honest with you. I would prefer IISc or IIT Bombay because IISc has more research focus and IIT Bombay is okay-ish. It's not bad, but as compared to IISc, where the focus is mostly research. So I would prefer IISc or IIT Bombay, but we have seen people who went to IIT Bombay for data science and they've done phenomenally well for themselves. So no worries about that. So Gaurav has a question which is, I watched the video and apply what you said, but when I see a random question from a subject which I'm not currently studying, then I could not solve it. That happens, Gaurav. That happens to all of us. So what you're literally saying here is, whatever subject you're studying, when you're solving problems, you're solving them. But let's assume you have studied a subject 2 months back that you're not able to solve. That's mostly because of lack of practice or sorry, lack of revision, I'm sorry, lack of revision. That's why we say revise at the end of every week, revise at the end of every month, revise at the end of every quarter or 3 months. These multiple revisions are necessary because we all forget, right? Even before Discrete Maths started, I took all of our notes that we give you, right? Publicly available to everyone. I actually take that notes, I highlight it on my iPad. I just make short notes because I also have to revise before I solve problems and explain you, right? We all forget. Like it's been a while that I've used some of the concepts in graph theory, especially groups, because I don't work in cryptography, right? So there are some concepts which all of us forget. That's why we have to revise. Even I do it on regular basis. Before a subject starts, I take a couple of days, revise everything, solve a bunch of problems myself, because otherwise I will not be confident myself. Happens to all of us, it's only natural. Cool. So somebody says, okay, this is Lakshmi Narayan says, I'm studying mechanical third year. I've completed C and TOC. Which subject is good next? Pick any subject because you're in a mechanical engineering. Pick any subject. We strongly recommend that since you've completed TOC, try and complete compiler design because those subjects are connected. And then after compiler design, you can do data structures, algorithms, etc. because that's a very nice subject and programming obviously, because that will also prepare you better for your placements in the final year for IT jobs. Okay, cool. Can you display IIIT Hyderabad PG stats? We don't have the stats, unfortunately. If you're talking about placement stats, I think one of our co-founders studied there. I think he got the data from the placement cell by talking to them. But I think most IITs and IIITs and NITs publish their placement, at least high-level statistics, if not the nitty-gritty details. Okay, cool. Are IIITs good if you have more interest in programming? Yes. IIITs, especially IIIT Hyderabad, is designed keeping the industry needs more into consideration. So in my own experience of hiring from IIIT Hyderabad, they are very good programmers. I mean, they are better programmers than what I've encountered at other IITs also, to be honest with you. Because programming is so central to their curriculum. A lot of their curriculum revolves around actually implementing things, whether it's operating systems, computer networks, whatever it is. So they tend to be slightly better programmers, both undergraduate students and master's students. Cool, sounds good. Sounds good, folks. All the very best. Thank you very much for joining in this session. Again, we will meet in a public session on YouTube the next Tuesday. For all the course enrolled students, we have the next session on Friday. We will send you the link to join that session. Thank you very much. Bye-bye.